Actually did see that. Even my brother was like 125, but I think that guy. We could have saved that. They're like, it's the map that runs down. Super game. See, it's like on top of the bunks, and the little Thanos laser. You must have the girl.
All right. Okay, y'all, I'm a little bit losing my voice, so I'd love to not have to shout so much today. Okay. Okay, so we are going to run through this little single sheet, and then I'm going to show you how to do some stuff on the calculator, and then you should have at least half of class to just work on stuff, okay? So take a look at number 1. Okay, if you have a position function, okay, it tells you its position. Okay, how do you find velocity? You should know this from the last 2 weeks. Very good. So velocity, okay, let's put computers away for now, please. Okay, velocity would be the derivative of t cubed minus 2t. That would go to 3t squared minus 2. Now, that's the velocity at whatever time that I want. What about if I want the velocity specifically at 2 seconds? What would I do? Great. So v of 2 would be 3 times 2 squared minus 2. And I would just take that number, plug it in here, yeah? So 2 squared is 4 times 3 is 12. And what's 12 minus 2? 10. So your rate of change or velocity would be 10. And then if position is measured in feet and time is measured in seconds, it would be feet per second. Okay, so hopefully we already know that. Okay, if you want the average velocity, okay, so this is the velocity at 2. So like if you were driving in your car at whatever, we'll say 2 seconds, it's your exact speed. If you want an average velocity, you're going to do the slope formula, which would be v of 2 minus v of 0 over 2 minus 0. Okay, so average velocity, rather than being at a specific moment, okay, it's going to be across an interval of time. You're going to use this formula right here. Now, just to kind of prep you with some calculator stuff, Desmos, sadly, is not an option for you guys. You have to use this guy. So let's see what we know how to do. Go into y equals, type this equation in. So it's t cubed minus 2t, we're going to use the x. So x cubed minus 2x. Okay, once you have done that, I want you to second quit to just go back to the regular calculator screen. Second quit. So you should be just on the regular screen like this. Okay, I want you to hit alpha x to open your pretty fraction. And then in order for you to find the y value at 2, you're going to hit alpha trace y1 at 2 minus alpha trace y1 at 0. And what that's going to do is it's going to find the y value for you at 2, find the y value for you at 0, and then subtract them. To get the y1, so you'll hit alpha trace, and then you'll pick the y1 option, because that's where you typed your equation into, was under y1. So it's y1 at 2 minus y1 at 0, and you're putting the parentheses there yourself. Okay, and then over 2 minus 0. Alpha trace pulls up your y1. Okay, Abdullah, we have a calculator.
Yeah.
Okay. Then Yaya, do you have a calculator? Because for your homework, you'll both need your own. All right, you should get 2. Okay. 2 minus 0. So it just looks like this. Okay, so good or no?
I'll put that in.
Did you type the equation into your white?
Oh, I want to. Oh.
Wait, go to.
So it's study the hour.
Yeah, we need so.
Same.
Clear around the clear. So.
I only say Calc. Yeah, I'll get biceps and triceps. Logan. Huh? We exchange numbers.
So.
I was actually considering going to Kansas afterward, but I was like, damn, I like.
So you need that votes to be one, but then not 2. Okay, do y'all have it in the calculator? Okay. Y'all have it in the calculator? Okay. All right. Okay, so there are 2 types of velocity. If you take the derivative, you are getting the instantaneous rate of change, or the derivative at a particular instant. We're going to call that IROC for instantaneous rate of change. Okay, versus the second one is going to be AROC for average rate of change. Okay, and the big difference is that IROC is at an instant, AROC is over an interval. So let's write down here under our summary. Okay, the derivative of position is velocity, but there are 2 types. Okay, if you are doing the derivative one, that's the instantaneous velocity. Instantaneous velocity at a particular time. Okay, versus the second one is an average velocity. And that's going to be over an interval of time. Okay. So derivative is at a particular instant. Okay, average rate of change is across an interval. You'll use this slope formula. All right, go down to the bottom part of this. So let's do the same thing for velocity. What is the derivative of velocity called? Acceleration. So if I want the acceleration at any time that I want, I'm just going to take the derivative. So A of t would be 6t, and then the minus 2 is gone. Okay, then if I want the acceleration at time 4, I would just take the 4, plug it in. What would I get for my acceleration at 4? 6 times 4 is 24. Now, we haven't really gotten into units a bunch, but if velocity is feet per second, what would acceleration be in? Feet per second squared, very good. So if I take the derivative, that's the instantaneous rate of change. But if I want average acceleration, that's the average rate of change, or the slope formula. So if I want it over the first 4 seconds, your interval would be 0 to 4. Which means I'm going to do the velocity at 4 minus the velocity at 0 over 4 minus 0. Okay, but notice this is the slope formula of velocity, but the slope of velocity is acceleration. Okay, or average acceleration in this case. So when you're ready, we're going to repeat the process. Type this into your y1. So erase your original y1 and you're gonna put this one in. So it's 3t squared minus 2. That's your velocity. And then I want you to practice typing in your slope formula, okay, using the little shortcuts that I gave you. So once you have it typed in, you're doing alpha x, alpha trace y1 at 4, minus alpha trace y1 at 0, over 4 minus 0. Should be 12, very good. And then what are your units for 12? Feet per second squared, because whether it's an instantaneous acceleration or an average acceleration, you would still have the same unit. Okay, then at the bottom, v prime, or the derivative of velocity, is your instantaneous acceleration. Versus if you do the slope formula on velocity, you're getting average acceleration. Okay, so instantaneous acceleration is at a particular time. And then average acceleration is over an interval of time. Okay, so that being said, turn the page. Okay, you know how to do it if you have the equation. If they give you a table, okay, then it's even easier because you don't have to use the alpha trace stuff. So turn the page, look at the first example. What is given in my chart? Is it position, velocity, or acceleration in the next example? Position. Then when I take the slope of position, what function do I get? Velocity. Very good. So if I want the average velocity over the first 6 seconds, what interval is that referring to? From 0 till 6. Okay, and then remember, for average velocity, I'm going to do the position at 6 minus the position at 0 over 6 minus 0. Okay, but I'm doing the slope formula on position because the slope of position is average velocity. Okay, then I can just find the numbers from the chart rather than having to alpha trace. So what is the position at 6? 8.2 minus what's the position at 0? 0.4, and then over 6 minus 0, and then you can just put that into your calculator. So remember, your little fraction shortcut is alpha x. Okay, for the bottom, you could just put a 6 instead of 6 minus 0 if you want. You should get 1.3. Now, this is an average velocity. Position is measured in meters. Time is measured in seconds. What would velocity be measured in? Meters per second. Very good. Okay, now the next question says to estimate the velocity at 0.5. Okay, question. If I want the velocity, not average, but the actual velocity, what do I need to be able to take the derivative? I would need what type of information? Not a table, but I would need the equation. Yeah, and I don't have that. So if it says to estimate the velocity, then I'm going to do the average velocity around the smallest time interval that includes the time that I actually care about. So if I want to know the velocity at 0.5 seconds, but I don't have an equation to take the derivative and plug in 0.5, then the best I can do is to find the average rate of change over the time interval that surrounds that point. So if I want 0.5, what time would surround that point? 0 to 1. Okay, versus what if I wanted it at, let's say, 5.5, then you'd go between 5 and 6. Okay. And then remember, your formula for average velocity would be the position at 1 minus the position at 0 over 1 minus 0. But you're doing the slope formula on position because the slope of position is velocity. My x of 1, the position is 1.7 minus 0.4 over 1 minus 0. 1.7 minus 0.4 is 1.3. And then divide by 1 meters per second. Okay, it is a coincidence those came out the same. They won't always. All right. Take a look at the last example. What is in your chart? Velocity. And if I take the slope of velocity, what do I get? Acceleration. Very good. Remember, there's two types. I can only find the exact acceleration if I have the equation, which I don't have. So if I want the average acceleration, then I'm going to use this slope formula. So I want it on 8 to 10 seconds, then I would do the velocity at 10 minus the velocity at 8 over 10 minus 8. And then for this example, you can just pull the numbers out of the chart, put it in the calculator and divide. So V of 10 is how many? 10 would be 15, yeah? Okay, and then at 8, it's 11. On the bottom, 10 divided by 10 minus 8 would be 2. 11 minus 15, or sorry, 15 minus 11 is 4. Divide that by 2, what do we get? 2. Meters per second, what? Squared if it's acceleration. Okay, so acceleration is meters per second squared. Now look at part B. It says to approximate A of 3. I can't give the exact acceleration at 3 because I don't have the equation to take the derivative and plug it in. But what interval surrounds 3 that I could find the average acceleration on? 2 to 4, very good. So you're going to use the average acceleration, or AROC, on 2 to 4. And you really want to try to pick the shortest interval around that number. So you would not want to go like 0 to 6. Even though 3 is in the middle of that, okay, you would want to pick the smallest that you can kind of squeeze it in. So it'd be the velocity at 4 minus the velocity at 2 over 4 minus 2. Hey. 8th graders? Oh no, I didn't volunteer, sorry. Oh, okay.
I think there's like 8th graders out.
Yeah, they're like shadowing avid students. So, okay, then V of 4 would be 15. No, 12. Minus V of 2 would be 15. Final answer for that, what would my fraction be? Negative 3/2 meters per second squared. Okay, now, quick question. If your average acceleration is negative, what does that mean velocity was doing over that interval? Was it going up or down? Down. If your acceleration is negative, that means velocity was decreasing, right? Okay, so we're going to get super into your calculator for one question, and then we're going to move on to homework. So if you'll get out your notes from last time, we're going to finish one page, the calculator practice page. Okay, so pull this guy out of your notes from last time. Y'all have notes from last time? Anybody need a copy?
I need
What?
I still have this.
It's
I saw you pitching the other day. I almost great there. Yeah. Yeah. It was at like 5:30.
Oh, I thought that was all. Thank you. Yeah, like. I do. Yeah. Okay.
Yeah.
All right, before you type this in, I want you to reset your calculator. So it's second plus 712. Okay, second plus 712. You're going to reset your calculator. Okay, all the pre-calc kids, just put it in degree mode. You need it in radian. So second plus 712. Yeah. Oh, you really? No, I didn't know that. Wow. Wow, you taught me something today. Okay, then type this in. You're so late, silly girl. Oh, for the 8th grader thing? Yes. Okay, that's fine. Will y'all just, are you staying or you're about to leave? Okay, so we're finishing the last page off of last time's notes, and then there's just a 1 pager. Okay, I'll grab it. Okay, have the best time. Be nice to those little 8th graders. Okay, type that into your y equals. Okay, the faster that we get through this, the faster we're done. So type it in. Y equals, put that equation in. Okay, if you didn't reset your memory, your answers are going to come out wrong because you're in degree mode. Second plus 712. Yes, ma'am. 1 plus 2, sine x squared over 2. We're typing this in right here. Yes, we are.
You can just.
Wait, what did you do?
Y equals, go up, press there, I'll take you back.
Oh, okay.
I did not know that. Oh,
Barrett's like a calculator wizard.
ever since I used the graphic calculator, I would just wait for it to go super slowly to make the graph and I could see it.
Wow.
I'll show you for my ACT.
Yeah.
All right. Are we ready? Okay. Okay. So, girls, you ready? Okay, first thing I want you to do in your window button is I want you to restrict the x-axis to 0 to 4. Okay, if you don't know how to do that, I'm going to show you. But if we have to go over stuff a million times, this page can take 15 minutes or it can take 30. So watch me do it, then you do it. Hit window. You want your min for the x to be 0. You want the max for the x to be 4. Don't change anything else. So I pushed window. I adjusted my min to be 0, my max to be 4. So that when I hit graph, I'm only looking at the 0 to 4 section. Okay, then sketch that onto your sheet here. So it goes here, like that. Okay, question. What equation did you put in your calculator? Is it a position, a velocity, or an acceleration? Okay, V of t means that this is a velocity graph. Okay, so once you have that sketch, we know our end time here is 4 seconds. It says in part A, how many times does the particle change direction over the interval from 0 to 4? How many times does it pass through the x-axis so that velocity changes sign? Okay, the answer is twice, here and here. Okay, let's figure out how to find those. So I'm going to put t equals here and here. Okay, in order for you to find those, you're going to go back into your y equals. And you're going to go into y2. Don't delete the original equation you have. We want our graph to hit the x-axis, which is the same as 0. So your y1 is the velocity graph. Your y2 is going to be the velocity you want it to hit, which is 0. Everybody got that? Okay, then hit second trace. and you want them to intersect. Okay, you'll notice your original velocity graph is still there, but now your x-axis is red for 0. It's going to ask you for the first and second curves, but listen, you only typed in 2 equations to begin with. So you can push enter, enter, and then when it says guess, you're going to get closer to the intersection you want to find. So I'm going to start off closer to this first one, and then I'm going to push enter. Okay, you should get 2.7074. 2.7074. And then the 4, we'll leave it the same. Okay, for the second value, second trace, 5 for intercept. Enter on the first curve, enter on the second curve, then get closer to the other intersection. And your second intersection should be 3.3939. So I'm going to round that to 3.4, 3.394. Okay, now how do we know the particle changed direction? Because velocity changes sign. And when velocity changes sign, we know the particle would have changed direction. So it's the same thing that you did last class, but now you're having to find where those values are. Okay, then it says, when did the particle travel to the left? Do I want a positive velocity or a negative velocity? Travel to the left means I need my velocity to be negative, which means below the x-axis. V of t less than 0, which means below the x-axis. Which means that it would be from here to here. But now that we know what those numbers are, we can put it'd be from 2.707 until 3.394. Okay, next question says, when do I have a minimum position and a maximum position? Remember, that depends on the direction the sign change happens. So if I'm here at this spot, how does velocity change sign? Plus to minus or minus to plus? This is from the positives to the negatives. So now think about my velocity went from positive to negative. Is that a max or a min? This is a max, which means that this one is a what? A min. Very good. So in your calculator, you're going to put that at t equals 2.707. We have a relative max. Because v of t changes plus to minus. Okay, but remember, we already did this last time. You're just now finding those values yourself. At t equals 3.394, you have a relative minimum. Because v of t changes minus to plus. Okay. Next question says, is the particle going towards or away from the origin at 4? There are 2 things that you need to answer that question. You need to know the position at 4, and you need to know the velocity at 4. Now, question, if you're looking at a velocity graph, how will I find the velocity at 4? What do I need? Plug it in. So we need the y value. Yeah. So there are 2 places that you can find it. Okay. The first one is you could look in the table and then just scroll down to 4. Okay. But the second place is in your regular calculator. You can do alpha trace y1 at 4. Okay. Now, why would I need you to know this way? Because your table only lists whole numbers. So if you wanted the velocity, let's say at 3.6, that's not going to show up in your table, but you could do y1 at 3.6. So go ahead and write down 2.978, which is going to round to 2.979. And then I'm gonna put next to that, that's the Y value on this graph. You can find it in the table, or you could find it using alpha trace Y1. Okay, but the other thing I need is position, and when I'm looking at a velocity graph, can position be found there? No, because remember, every time you take the derivative, you lose a little bit of information. So look back at the last sentence of your question. What does it tell you the position is? Okay, right here, the particle is at position 2 at time 4. So your position at 4 is 2. And then I'll put given in prompt. Okay, so now consider your position is positive. Are you on the left or right side of the origin?
Right.
Okay, so particle is on the right. And then if your velocity is positive, which way is it traveling? These were both positive values. So it's on the right and it's traveling right, then is it going towards or away? There you go. Therefore, away. Okay. All right, next question, part D. Says the particle's acceleration at time 4, is that an instantaneous rate of change or an average rate of change? Time 4 means this is an instantaneous rate of change, which means you want to take the what? Starts with the D. Derivative. You're not going to take it by hand, though, if it's a calculator question. So go back to your calculator. A of 4 means that I want to take the derivative using the calculator. So let me show you how to do that. Go back to your regular screen. You're going to hit Math 8. You're going to put an X in the first box because it's ddx. And you're going to put alpha trace Y1 in box number 2. So this is the derivative of Y1 at whatever X I want. What X do I want? 4. So in this box, I'm going to put a 4. So it should be dd, and then you're putting the X in. And then alpha trace Y1 in the big box. And then a 4 as the X value that you want the derivative at. Okay, so that is calculating the exact slope of that graph at 4. So we got negative 1.164. Negative 1.164. Now, if I wanted average acceleration, okay, which this question doesn't ask, but we're going to add it. So find the average acceleration. Let's say over the first 4 seconds. What would I do for average acceleration? V of 4 minus V of 0 over 4 minus 0. And remember, this is called the slope formula. That's y2 minus y1 over x2 minus x1. Okay, so go ahead and find that value next. So open up your fraction, alpha trace, y1 at 4 minus y1 at 0 over 4 minus 0. So you should be able to take the derivative in the calculator and find the average slope across an interval. Okay, it's 0.494 followed by a 6 would be 0.495. Okay, both of those though would be meters per second squared. The only difference is one of them is an average across an interval versus that's at a particular time. Okay, last thing, let's answer. Is it speeding up or slowing down? What 2 things do we have to look at for speed? Okay, y value, which is velocity, and acceleration. What type of number is velocity? Positive. What type was acceleration? Negative. Then what would your answer be for speed? Let me know. Okay, So get out your calculators and your computers and let's get into our homework. Okay, there's one example we need to do together, but we're gonna wait a little bit and let you figure some stuff out first. Okay, all of the questions off of last time's homework that I had you skip, I deleted them and moved them to their own homework today. So you don't have to go back and finish homework 3, those questions we skipped. Okay, so I can ready for that. You're welcome. Yeah.
Yes.
All right, so average velocity, you're doing the slope formula over what time? Well, hold on, but this one you're holding over time. So what is the so it'd be 49 minus. What is B at 40? 9 over 69. You see what I'm saying? Versus if they gave you the equation, that would be correct. Yes. Huh? Oh gosh, as you can see, I think this question is nice and so.
Okay.
Yeah, this is,
All right, y'all good back here?
Yeah.
Hey, yeah. Any help? I love to help.
No.
Anybody else needs correction? Yeah. Okay.
So for this one.
Yes.
This is the right way to do it.
You're doing it on, so if you want it at 8, you go 0 to 10, so you did 130, yeah, that's right. Very good. So if it says average velocity, you're gonna do this one. So you'll take the velocity from 40 to 60 would be v of 60 minus v of 40 over 60 minus 40. But since it's a table, what is it at 60? 49 minus, what would it be at 40? 9. So 49 minus 9 over 60 minus 40. So you're doing y2 minus y1 over x2 minus x1. Yes. 40 minus, wait. Hold on, wait. Oh, it'd be 40 over 20. Yes, that's correct.
40.
And then what is 40 divided by 20? 2.
So
Yes.
I took the derivative, right?
No. If it says average, you don't take the derivative, right?
Right.
So you want to type this into your y1. And then if you're doing it over the first 3 seconds, you would do f of 3 minus f of 0 over 3 minus 0. You see what I'm saying?
No.
No?
So I do second quit and then I do
Uh-huh.
this thing.
Yeah. Alpha trace, Y1 at 3. Because you're doing an average over the first 3 seconds means you're going 0 to 3. So it'd be Y of 3 minus Y of 0. Okay, we have 45 minutes. Let's get some work done. I'll show you, okay? Alright, I think you did. Hang on, let me do this. Okay, so if you want approximate velocity at 8, then you're gonna pick where 8 fits between and then find the average velocity around that time. So 8 would be 0 to 10, yeah? So open up your fraction. You'll do 136 minus 100, subtracts the y value first. And then over subtract the x values. So what would that be? 10 minus 0. Yeah, you don't have. Yeah, okay. All right, Sydney, you ready to get started? No, Chester. All right, how are you doing? You done? Anything done? No.
Okay, which one are you on? This one? Okay, so if you're looking at a velocity table, acceleration is the slope. Do you want the derivative or the slope formula?
Average acceleration.
So that slope formula. And then if you want it over 8 seconds, you'll do 5 minus 3 over 8 minus 0. You do y2 minus y1 over x2 minus x1. Yes, Leo.
So it's 5 minus 3 over 8 minus 0.
For first 8 seconds, correct. Wait, hold on, say that again. 5 minus 3 over 8 minus 0, correct. Now,
Wait, hold on.
what's 5 minus 3? 2 over 8 minus 0 is 8.
Yeah, probably 5.
Why does it hurt? You don't like what I taught you today?
No. Like I feel like it, but I just don't want.
Not here. Nobody's not here. I think Benji Dyson. Okay, what question are you on?
Wait. I know. We got something to say, Garrett.
You figured it out? Oh, sorry, you told me you got it wrong, then I started ignoring. Oh, okay, good, good, good. Wait, snow when, Monday?
Or like.
What if we got another snow day?
They said it's like.
Like 19 degrees or something?
Friday, it's just down like.
We can only hope.
What's something on a Friday? What's for next week?
Okay, finish maybe the one that you're working on, and then we're gonna do the very last question together. Okay, finish what you're working on. You have your.
Dude, honestly, at this point, like, I like stuff. I didn't want to pay this. I'm just trying to get out. I never want to see it. Like I said, car is one of my part. I really wanted to keep. Cars are just.
I know that.
Wait, what are we doing on that one? What's your velocity at 0? Does that mean it's going left or right?
Right.
Okay, good. Now, position's not gonna be in a velocity chart, but they'll put it in the question. What does it tell you the position is? 7. So if it's on the right, because it has a positive position, and it's traveling right, correct. Very good.
You drive around? You don't know that. Yeah, but like that.
All right, go ahead and skip to the very last question. Type the equation into your calculator. Type the equation into your calculator. Okay, very last question. Very, very last question. Okay, and then unless you have a calculator at home, you really need to do this homework like today. So I know Fridays suck, but try to really use, that's why you have so much time today to work. Yes. Am I on the not the right question? Oh crap. Okay, sorry, I'm on the wrong one.
Sounds like that isn't. I don't think I've ever had it bad.
Really? What'd you have for breakouts? Oh, aren't you sad he left?
Yeah. I think you wrote me a letter of recommendation.
Oh, and then who'd you have for geometry, Miss Bess? You in Sherman? Wow.
I took geometry first. It was different.
Yeah, most schools do it in that order. Okay. All right, from here, you should have the equation typed in. What type of equation? What type of equation did you put in your calculator? Velocity. What do you want to find? Acceleration. Is it average or at an instant?
Instant.
At an instant. What instant? 5. Then you're going to take the derivative at 5. So in your calculator, once you've typed it in, second quit. How did we access the derivative? Math what? Math 8. And if you forget, do you see how it says n deriv? That means derivative. Okay, then dvx y1 at time 5. Okay, so you're not taking any of these derivatives by hand. You're just putting them in the calculator. Okay, then you're rounding to the thousandths place. So that'd be 3 decimals, so negative 1.628. That'd be your answer. Negative 1.628. Good on that? What if it asks for average acceleration? Then rather than the derivative, you do the slope. Okay, last question we're going to do together is 5 up from the bottom. 1, 2, 3, 4, 5. Okay, go ahead and type the equation in. 5 up from the bottom. Five up from the bottom. X 0.7 cosine x minus 2. X in the first box, Y1 in the second box, and then 5 in the third box. Okay. All right. Once you have this typed in, what interval are you needing for your window on your graph? From 0 to when? 6. Now, the example you have in your calculator right now is only 0 to 4. So your window is not going to be big enough. So go to window, and you're going to expand your max to go from 0 to 6. So the second digit, instead of a 4, you want it to be a 6. Then hit graph. Now, what type of function are you graphing? Position, velocity, or acceleration? This is velocity. And now read the question with me. We didn't do one like this in the notes. It says, find all the times when the speed is equal to 1. Now, we did find the speed equal to 0, but we didn't do it with 1. So in your calculator, you're going to go back to your y equals, and you're going to let your y2 be a 1. Because I don't want speed 0 this time. I want speed 1. And then you're going to find the intersection. Okay, so second trace, and then intersect. Now, looking at your picture, how many times is this one going to cross? Twice. So remember, you'll push enter on first curve and second curve, and then get closer to the one you want to find. Okay, so I'm going to find the first intersection if you want to find the second one. So the first one I found is 1.364, comma. Then you find this one. Don't push enter yet, though. Okay, so for my second one, second trace 5, 3.100 is going to go to 3.101. Don't push enter. Okay, here's why. Remember that speed is velocity, but without what? Without direction. Very good. So if I'm going 1 mile per hour, that could be positive, or it could be what? Negative. So go back into your y equals. A velocity of 1 is a speed of 1, but a velocity of -1 also would be a speed of 1. And then you'll look and see if you have another intersection, which you should have one. So your velocity will come through first, your -1 will come through second, and then you'll have one more intersection to link into your answers. So remember, it's second trace 5 for intersect, and then get close to that one and find the third one. Okay, but the reason you have to set it equal to 1 and -1 is because it says speed. And so your velocity could be 1 or -1. Both of those would count as a speed of 1. And then remember, you're going to the third decimal. Did y'all get the last one? And then this one, since it only crosses once, you don't have to really get close to it for the guess, because there aren't like multiple choices. So it should be 3.962. You said you don't get it?
Well, make it absolutely 1.
Say it again.
I'll make it absolutely.
What do you mean absolutely 1?
Like the y is.
So I went into my y equals. Do you mean like to use an absolute value? So I just went in and changed my 1 to a -1.
Right.
So first I let it be 1, I found those intersections, then I changed it to a -1 and found those intersections. That doesn't matter. Your answer should come out the same. So you remember, if you're on guess, you have to still push enter one more time. So you did second trace 5, right? Then enter. And then on the guess, you just get closer to whichever one you want with there. So like, let's say you want to find this one, arrow back towards that one. Oh, it's just like arrow this one. You see what I'm saying? See how they cross over here? And then on guess, you'll just push enter one more time, and the answer is gonna match mine. So over your. You did 0. Yeah, you did 0.7. But just copy mine. You understand how to do it. Good job, guys. Okay. Oh, wait, no, second trace, option 5. And then enter, and then on guess, you get close to where they intersect, but you're already close to it. So just put enter again. That's right.
I thought we had to like shimmy it, I was like.
No, you won't, the only time you